Hi, my name is Allison Meidel, and today I'll be discussing the experiment titled Chemical Equilibrium. So the purpose of this lab was to determine how changes in concentration of reactants and products affect chemical equilibrium. Chemical equilibrium occurs when chemical reactions do not go to completion. There may be more or less of the products compared to reactants, but forward and reverse reactions happen continually at the same rate. Changes in chemical equilibrium can be predicted by Le Chatelier's principle. Le Chatelier's principle states that a system at equilibrium responds to a stress in such a way to minimize the effect of the stress. So the experiment was 6 equilibrium systems were created and observed, and different stresses were added to each equilibrium system, and observations were recorded as to what happened to the solutions. So the first equilibrium system that was created was acetic acid and acetate equilibrium. So acetic acid was taken and the pH was found to be 3 with pH indicator strips. And then sodium acetate was added and the pH changed to 7, which indicates that it shifted to the left because a rise in pH means that there are less H plus ions in the solution. And in the balanced equation, H plus ions are a product. The second equilibrium system that was created was chromate and dichromate equilibrium. So a chromate and dichromate equilibrium was established, and it was observed to have an orange-yellow color and was very bright. And then hydrochloric acid was added to one of the samples, and then sodium hydroxide was added to the other sample. It was observed there was no change when the hydrochloric acid was added, but when sodium hydroxide was added, the color changed to yellow. And then the hydrochloric acid caused a shift to the left because it was known that the CrO42- was a yellow color and the CrO72- was an orange color, and the CrO42- is a reactant, so when the sodium hydroxide was added, it turned yellow, indicating a shift to the left. And then hydrochloric acid was re-added to the solution, and it turned back to the bright orange-yellow color, indicating a shift back to the right, because the hydrochloric acid added H plus ions, and H plus ions are the reactants, and it caused a shift to the right to equalize the products and reactants. The third equilibrium solution that was made was bismuth trichloride equilibrium. The solution, when it was made with bismuth trichloride and 2 milliliters of water, and it created a milky color, and then hydrochloric acid was added and it turned into a clear solution with a white precipitate. And the reason this happened was because the hydrochloric acid caused a shift to the left because it added H plus ions, which are a product, and the reaction shifted to the left to create more reactants to stabilize the equilibrium, and the bismuth trichloride precipitated out. And then water was re-added and it reformed the milky solution, indicating a shift back to the right because water is a reactant, and then more products were created to recreate the equilibrium again. The next reaction that was studied was the cobalt chloride reaction equilibrium. So the COH2O6 was pink and the COCl4 is blue. And when the cobalt chloride aqueous solution was made, it was observed that it was a light purple pink. And then hydrochloric acid was added and it changed colors to a purple-blue color. And this indicated a shift to the right because the acid removed water, and which was a product. So the equilibrium shifted to the right to make up for that. And since it changed to a blue color, it was also known that it shifted to the right because the COCl4 was blue, and that is a product. And then heat was added to the equilibrium system, and it became an even darker purple-blue color. And it was known that this shifted to the right because the COCl4 in the products was a purple color. And then heat was removed, and the solution changed to a light pink color, and this indicated a shift to the left because the reactant COH2O6 is pink, and more of the reactant was made. And these shifts indicate that the reaction was endothermic because it requires heat for the reaction to occur. The next reaction looked at was iron-iron thiocyanate equilibrium. So the iron-iron cyanate equilibrium was created, and it was a dark orange color, and it was known that the iron ion was yellow, the SCN minus was colorless, and the iron CSN2 plus was a dark red. So first heat was added, and the solution became a lighter orange, which indicates a shift to the left because the reactants were a lighter color. And then more iron nitrate was added, and it became a darker red, indicating a shift to the right because the products on the right were darker. Then KSCN was added, and it caused the shift to the right because this is known because it became darker and the ions on the right side of the equation are darker. And then AgNO3 was added, and a milky substance was formed with a solid white precipitate, and this indicated a shift to the left because SCN minus was lost in the precipitate and then it had to be replenished. And then finally NaOH was added, and a clear solution was created with a dark red-orange precipitate, and the Fe3 plus was the precipitate, and this caused a shift to the left in order to replenish the Fe3 plus that was lost from the precipitate. The next reaction looked at was the bicarbonate carbon dioxide equilibrium. So sodium bicarbonate solution was made with bromothymol blue indicator, and a bromothymol blue indicator will be blue if the pH is greater than 7.3, and it was, so it indicated that the solution was greater than 7.3. And then hydrochloric acid was added, and the color changed to a green tint, which indicated that the solution was lower pH, and this indicates a shift to the left because that means the lower pH means less OH minus ions, and the OH minus ions were products. And then the solution was put under the stress of aspiration, and it created bubbles indicating a loss of CO2, which was a product. So this caused a shift to the right to regain the lost CO2, and it turned back to blue because a shift to the right made more OH minus ions, increasing the pH. So in conclusion, the experiment showed clearly how Le Chatelier's principle worked because all of the chemical equilibrium systems responded to a stress in a way that would reduce the stress applied to the systems. And those are my references.